Hello everyone, this is Mrs. McCrary. Today we're going to talk about equidifferent numbers as discussed in elementary treatise number 1, section 127. In section 127 it says, in equidifferent numbers, the second term is equal to the first term increased by the difference, and that the fourth term is equal to the third term increased by the difference. Okay, so let's just look at that first section. So here we have the numbers 2 and 7, 4 and 19. So here's our first term, our second term, our third term, and our fourth term. So it says the second term is equal to the first term increased by the difference. So we would have, easy way to write that would be 7 equals the difference plus 2. So in this case our difference is 5. And let's look at fourth and third. So 14 equals difference plus 9. Again, we have 5. All right, so that's what that section is talking about. All right, hence it follows that the sum of the extremes composed of the first and fourth terms must be equal to the first increased by the third increased by the difference. So we would have 2 over 7 9 over 14. So the sum of the extremes, that's going to give us 16. All right, so then the sum of the extremes composed of the first and fourth terms must be equal to the first increased by the third increased by the difference. So then we would have 2 plus 9 plus our difference, in this case is 5. So 2 plus 9 is 11 plus 5 equals 16. All right, that also holds true. All right, also that the sum of the means composed of the second and third terms, so 7 plus 9 equals 16, must be equal to the first increased by the difference increased by the third. So 2 plus 5 is 7. Oh, I'm sorry. 2 plus 5 plus 9, there we go, equals 7, 16. That's fine. And then, let's get rid of that line. These two sums, being composed of the same parts, must consequently be equal. So this is just a section talking about different groups of numbers and ways that they're related to each other, ways that they're in proportion to each other. Now they're not in proportion to each other in the same way that we've been working with, which is called geometric proportions, where we use the multiplication and division. Here they're in proportion to each other with respects to addition, and so therefore we would call them they're arithmetically proportional. All right, now this works in subtraction as well. So we have our first, second, third, and fourth terms. So 8, 5, 15, 12. So since 8 equals the difference plus 5, 15 equals the difference plus 12. Now, as I said, it does work in subtraction, so you would write it differently, but we can just go ahead and say that our difference is -3. Okay, so that these satisfy second term is equal to the first term increased by the difference, the fourth term is equal to the third term increased by the difference. Okay. Hence it follows that the sum of the extremes must be equal to the first increased by the third increased by the difference. So we have 8 over 5 over 15 over 12. So we have 8 and 12. So 8 plus 12 is 20. Let's check. Okay, so the sum of the extremes composed of the first and fourth terms must be equal to the first increased by the third increased by the difference. So we have our extremes, first and the third. So 8 plus 15 plus the difference, which in this case is negative 3, and that again does give us 20. Okay, also that the sum of the means, composed of the second and third terms, must be equal to the first increased by the difference increased by the third. Oh, my lanes are not straight, sorry. Okay, so the sum of the means, 5 plus 15 equals 20. And then we have a bunch of crazy lines. Sorry. Okay, must be equal to the first increased by the difference increased by the third. Okay, so we have the first, 8, plus negative 3, plus 15, again gives us 20. All right, so those are equidifferent numbers. We're not really going to talk much more about them other than just being able to see that they are in fact equidifferent numbers. There really isn't anything on how to solve for them or how to work with them, although you can, see that if we had if we had this scenario of 4, 6, I don't know, 10, on the surface, it would seem like, okay, so 4, 6, 10, well, clearly that would be 12, all right? I'm not sure if something like that would work with the other conditionals. Let's go ahead and check. Okay, so the sum of the extremes composed of the first and fourth terms. So in this case we have, okay, so 4 and 12 equals 16. So now let's see what we have. Must be equal to the first increased by the third increased by the difference. So 4 plus 10 plus 2 equals 16. And the sum of the means, composed of the second and third terms, must be equal to the first and the third plus the difference. So here, 6 plus 10 equals 16. The first plus the third plus the difference equals 16. So that one happened to work out. I'm not sure if in every scenario I just picked 10. Let's try another one. So we have 4, 6, 12, and then in this case, since we have a difference of 2, it would be 14. So we would have 4, 6, 12, 14. So the first and the fourth term is going to be 18. So our means is going to be 18. So first plus third, their difference is again 2, is again 18. Now let's try with our means. 6 plus 12 equals 18. First and third plus the difference, 4 plus 12 plus 2 equals 18. So that looks like it's working out pretty well. Go ahead and try a couple of those. See if you can find that fourth term, or if you can find, I don't know, the third term or the second term. And if you have any other questions about those, go ahead and let me know. Otherwise, I will talk to you at our live chat.